And with that, I would like to present the 2014 Founders Award recipient. This is Terry Shore, and this is going to be presented to Bill on behalf of Terry. And we have this really nice plaque that we make up every year, and this will be on display. And again, I'd like to present this to Bill on behalf of Terry, and please join me in congratulating the contributions that Terry Shore has made to forest entomology in the West.
Okay, thank you.
Thank you.
Thank you very much, Joel, and thank you, everybody. It is an incredible honor and quite humbling to be presenting to you this morning. It is a terrific honor to be presenting on Terry's behalf. My talk this morning is first going to cover a little bit of Terry's background, primarily his academic and professional background. And then I have really 3 chapters to this talk. The first outlines and just highlights a few of Terry's most significant contributions to our profession. The second covers some of his significant contributions to WFIWC and other professional societies. And the third chapter are just some personal observations and things that I've learned through the many years that I've worked with Terry. So Terry completed his PhD in 1982 at the University of British Columbia. John McLean was his supervisor. His research was on mass trapping of ambrosia beetles in sawmills. And he began to work at Forestry Canada, which is what we were called back then, in 1982. And he was at that time a forestry officer with a group called the Forest Insect and Disease Survey, or FIDS. And Terry began to have an impact right away. He authored the definitive and official FIDS survey manual in his time with them. And Terry was well qualified for this because he understood entomology enough to provide the diagnostics to understand what damaging agent you were looking at, but he also had enough of a statistical and sampling background to make sure that what was recorded could actually be analyzed and used in some way. So in 1985, Terry became a research scientist in the organization, and he moved to the bark beetle research group, where he began a collaboration primarily with Les Safranek in that group. Now that was an incredibly productive collaboration, and a lot of significant research came out of that. But one of the things that really stands out was the Shore-Safranek mountain pine beetle stand risk rating system, which was published in 1992. Now, before I talk about this system, I just need to set the context for the way things were in the early 1990s. So in British Columbia, we were not experiencing a big mountain pine beetle outbreak. There were some hot spots, but entomologists and foresters knew that things could get bad because of the massive amount of very mature and over-mature pine that existed in the province. The technological landscape is worth touching on too, because things were changing rapidly. Personal computers were starting to come onto the scene, and geographic information systems were really starting to become established. So this allowed spatial inventories. This sort of thing wasn't available much earlier than that. So this is a kind of an exciting time. And also at this time, in the late 80s and early 90s, a number of people were working on risk and hazard rating systems, primarily for mountain pine beetle. And you know, why were people doing that? And in part, we recognized that outbreaks were imminent, and there was a desire to be able to identify stands that were more susceptible and that were likely to suffer more damage in the event of an outbreak. This could allow some prioritization of management, silvicultural treatments, this sort of thing. And it also afforded the possibility to relate susceptibility to actually expected damage in the event of an outbreak. And that could be very useful for all sorts of forestry planning operations, that sort of thing. Now, one of the things that I really appreciate about the shore saffronic system is that they were very clear about defining terms used. Because at that time, a lot of terms were being used: hazard, susceptibility, risk, vulnerability, often interchangeably. And you didn't really know what somebody meant when they threw one of those terms out. So in the shore saffronic system, stand susceptibility is all about the inherent characteristics of the stand. So that's what susceptibility was about. They defined beetle pressure was about the magnitude and proximity of the nearest mountain pine beetle outbreak or population. And stand risk was the short-term expectation of tree mortality as a direct result of mountain pine beetle activity. So the premise of this system was that risk was a function of stand attributes and beetle pressure. And that sounds kind of obvious, but at that time, most susceptibility ratings and hazard rating systems were purely based on stand attributes. The shore saffronic system was one of the first to really pull the two together in a single system. The stand susceptibility was based on some broad stand characteristics that we know correlate well with mountain pine beetle activity: stand age, density, the amount of susceptible host basal area, and the location factor. That last component really is to reflect some of the climatic influence on mountain pine beetle activity. So in later versions of this system, climatic suitability index was subbed in place of location factor. But in this original system, it was a latitude-longitude elevation system, and scores were assigned to these and multiplied together. As I said, the beetle pressure index is about size and proximity, and the publication in 1992 described a way to come up with an index for that. And they're combined in an equation that looks like this. Don't worry about that too much, but it takes a shape like this when you look at stand risk index against susceptibility and beetle pressure. So it's a shaped curve that seemed to fit what we observed in the stands. Now, the significance of this particular system is really quite big. It's become universally adopted in commercial forest land management in Western Canada, just about everywhere that pine forests exist. So this has been adopted by government agencies, forest industry, and even used in parks sometimes. And it is currently in use in BC, and Alberta, and Saskatchewan. And further, the system itself has been incorporated into a range of other decision support and land use management tools. So in 1992, after publishing this, Terry's focus moved onto mountain pine beetle decision support systems. And decision support systems were kind of an exciting thing in this time, in the 90s, and it was because of this evolution of geographic information systems and personal computers that this was sort of where things were going at that time. So Terry made a case for, and he got funding to hire somebody for this work, and that was myself. Now, unfortunately, this picture is not 1992, it's a little bit later than that. I don't have anything from 1992 of the two of us together, but I'll talk about that a little bit later too. So we set about building a mountain pine beetle decision support system. And there's some pieces that we built. We created a Windows PC version of the standard susceptibility risk rating system. And I have to let you know that was for Windows 3.1. So this is the era that we're talking about. And we worked with several people, both in the province and in industry, to incorporate the system into their GIS system so it could be a part of their planning and their forest inventory. We also created a searchable literature database. And this sounds like such a simple thing, but you have to remember the state of technology at that time. The internet, as we know it, didn't exist then. The internet certainly existed, but the World Wide Web didn't. There were no web browsers, there were no websites, there were no there weren't even search engines at that time. It was a much more primitive sort of thing. So what we did is we simply took the most current publications on bark beetle biology and management and created a database front end and shipped this as a standalone product so we could send a diskette out to remote corners of the province or anybody that was interested in having access to this information, because they couldn't just go to a library and get it. This stuff was a lot less attainable back then. And so that seems like sort of a quaint product today, but it's one we received a whole lot of recognition for from people in the province. They really appreciated that. We also built a stand-level impact model called NPD-SIM. And we built an expert system with the Ministry of Forests in BC, but it was specific to a certain district. In the decision-making process, they would go through whether to allocate a stand to salvage, that is, don't try any treatment, or to some aggressive direct control. At that time, the province didn't have any published guidelines for this. That changed later, but this was sort of everybody was on their own then. Additional work we were carrying out at that time, a major thinning and spacing study that had a lot of different people working in it, some silviculturalists, ecologists, soil science people, and it was a long-term major study. We did work on other bark beetles, some Douglas fir beetle overwintering study, and stand susceptibility for Douglas fir beetle and spruce beetle, as well as some work in the north, spruce beetle in the Yukon. Now here is a picture of Terry. He is standing at the infamous and beautiful Spruce Beetle Trail near Haines Junction in the Yukon. And it's quite amazing that the outbreak there was significant enough that they put in an educational trail in this part. So computer technology kept advancing, and so did the mountain pine beetle. Things began to really heat up. So there was a desire to really take the decision support work we had done to another level, to make it more applicable and more relevant to the kind of situation that was developing in the province. And now we had the opportunity to do some spatially explicit landscape modeling that simply wasn't very possible before. You could do some spatial work in a geographic information system, but that was really static analysis. And we happened to see a talk by Andrew Fall. He came to our lab. He had just completed his PhD, and the result of his PhD was a modeling environment called CELES, or the Spatially Explicit Landscape Event Simulator. And CELES wasn't a model itself, but it was a platform in which you could build spatial landscape models. And the light bulbs went off. We thought, okay, this is great. We can take a lot of what we built and put this into an actual landscape framework. So we started collaborating with Andrew Fall. And a product was born called CELES MPB. Now, part of the impetus for that, aside from our interest in doing it, is that Peter Hall, he was the provincial forest entomologist in BC at the time. He came to us, and he knew about our decision support work. He had been quite a supporter of it. And he asked, could we use some of our modeling tools to suggest whether or not the management effort we're putting into mountain pine beetle, is it buying us anything? What would happen if we didn't do any management? What would that landscape look like? Could you do some modeling to tell us that? What would happen if we increased our effort in direct control, for example? And so we thought, yeah, we think we can. This is a pretty big challenge, but we worked with Andrew Fall and a bunch of other people in the Ministry of Forests and wound up building a tool that succeeded in that regard. So we applied this, first of all, in the Kamloops timber supply area, which is a region of about 1.3 million hectares. Our model is a spatial raster-based model, so the resolution of this is 1 hectare. So each cell in the model represents 1 hectare on the ground. Now CELES, and CELES MPB, had what was, for the time, a pretty neat approach to modeling. Quite a bit of the work previous had been fairly monolithic. You would kind of build a big model and you might attach things to it. This was really, really modular, and models didn't need to talk to one another. So They interacted instead rather indirectly by changing the landscape. So that was the feedback on these. That meant a domain expert could build a mountain pine beetle impact model, somebody else could build a harvesting model, somebody could build a fire model, and they didn't really need to communicate very much. They just had to agree on what they needed on that landscape layer, and these things could play nice. So it's very extendable. There's all sorts of nice things that come out of that, and it is an approach that's being used today. It makes a lot of sense as opposed to the monolithic approach. So the mountain pine beetle model was NPB-SIM, the model that we developed earlier on in the decision support system. And NPB-SIM, in this context, captured the mountain pine beetle life cycle within a cell. So given some initial conditions, how many trees are alive that are suitable, how many beetles are there, how many trees will be killed, how many beetles will emerge that next year, how many will disperse out of that cell. And then a spatial spread model would take those beetles and disperse them over the landscape over a stochastically selected flight period. So that would range to cover and anticipate some of the stochastic nature of climate and the unpredictability of that. We did model pheromone attraction in there, and most of the dispersal was local, that is cell to cell, but we did also simulate long distance dispersal, and we found that it was essential for models at this scale to capture what we observed on the landscape, because beetles do engage in this, and we needed to capture it. And that was quite a learning process, getting that to work right. The harvesting model was set up in consultation with engineers and planners, because we had to make sure that this followed realistically what happened in this district. So all constraints had to be followed, the rules of harvest had to be implemented, the volumes taken had to match in a realistic way what went on there. And we also built, of course, a direct control, which at that time was single tree treatments, primarily fell and burn, and a model was implemented for that. So this was used successfully to evaluate management strategies at the landscape scale. It was applied then in several districts in BC, and the model results did influence forest management strategy. Some of the big things that the province began to wrestle with as time went on was whether or not some districts needed an uplift and allowable cut, and what would the effects of that be. And simulation tools were a great way to at least provide some evidence for those decisions. And some of the pieces built and knowledge gained was used to build a very ambitious model called BC-MTB, which is in use today. It's a province-wide model, so it's very, very large scale, and it has been used to inform provincial policy, and that was the point of that model. So this is a very influential piece. Now, Terry wasn't the lead on that study. That was Marvin Eng at the Ministry of Forests, but it would not have been built without Terry. He was a critical part of that. So the last piece in this chapter that I'm going to present comes out of Terry's very last publication. And this, I just do it because it presents a nice framework in which to consider some of these tools that we've built. So we can think about landscape scale risk along a certain gradient. At one end, we can capture what I'd call structural risk. So this is all about the stand structure, the structure of the landscape, the physical attributes. We can also go along and capture functional risk, where we're actually capturing biological processes and their interactions on that landscape. And there's a range in between. As we move along this gradient, we're able to ask more detailed questions about our system. We also can better evaluate management. What happens if we double our direct control efforts? What happens if we don't manage at all and just let things go? We can also, at the farther end, explore process interactions, and sometimes that's really important. And in learning how to apply our long-distance dispersal, we had to do a lot of sensitivity analysis, and we found that certain processes did interact and were significant. And so that was an important piece of that. But of course, as you move along this gradient, things become a little bit more complex, and sometimes much more complex. Data requirements often go up. That also means costs go up, and sometimes time to deliver a product goes up, and uncertainty goes up in your model results. So a good example of structural risk is the shore-Safranic system. It's not explicitly capturing any dynamics, but it does capture something that is inherent in the stand structure. Another method that we developed, and I didn't present it here, is called connectivity analysis or connectivity assessment, really takes the shore-Safranic and puts it into a spatial context. Once again, we're not modeling any processes, but we are getting a better sense of how connected or fragmented this habitat is. And it tells us a little bit more about landscape level risk, and it also tells us a little bit about likely pathways of movement. Now, empirical outbreak projection models, these are data-driven models, and despite the complexity of it, BCMPB is actually an empirical model. It is data-driven, so the future is projected from past observations in it. And you do begin to be able to query the system for some management questions, do some things along that line. You're not often explicitly capturing processes, though. They're sort of implicit in the data that you're modeling, so they're not quite as detailed as the next stage, which are population models. And CELI's MPB is a population model. So now we are really fully trying to simulate and capture the processes that are relevant to the questions we're trying to answer. At the far end of this scale are individual-based or agent models. And we didn't do any of those for mountain pine beetle. They were being used largely when we were doing this for things like ungulate populations. So you actually model or capture the behavior of each individual in a population. And we viewed that as being not a very reachable thing to do with mountain pine beetle. But I will say that there are some efforts today on individual-based models for mountain pine beetle. And someone in our lab, Elliot McIntyre, and a postdoc he has, are building one right now. And it follows the same philosophy as CELI's MPB in that it's very modular. Models can be developed individually and just interact through a common landscape. So that's where that is going eventually. So to summarize Chapter 1, Terry published numerous scientific papers, technical reports, and book chapters, but he generally had a primary focus on applied forest entomology. And he had a real gift for taking basic research and turning it into something usable by forest managers. And that was his real passion. He wanted to see things come into use and be employed by government in the industry. And a great deal of what he's done is still relevant and still being used in forest management today. So I'm going to step on to Chapter 2, and this is professional society involvement. And I'll step back in time again. So Terry started in 1982. He became a research scientist in 1985 with the federal government. And he got involved very early on. This picture is from the 1986 Western Forest Insect Work Conference in Victoria, British Columbia. And I found it among Terry's things. I found it only very recently, and I was thrilled to find it. It was titled, Canada's New Wave of Forest Entomologists. And those of you who have been around will recognize a lot of people in the picture. Staffan Lindgren, Jerry Carlson, Russ Cousins, Peter Hall, Tim Abata, and of course, Professor John McLean, and there's Terry. So Terry jumped in right away. He became a WFIWC counselor in 1986. And shortly thereafter, he joined the organizing committee for the very first North American Forest Insect Work Conference. He was the only Canadian on that committee. In 1992, he was elected president of the Entomological Society of BC, and he was WFIWC chair in 1992 as well. Terry went on in 1995 to chair the organizational committee for the Entomological Society of Canada's joint annual meeting in Victoria, BC. And if you've ever organized a meeting of that size, you know there's just tremendous amount of work. It's really a stressful thing. But of course, Yeah, here's a picture of Terry at the registration desk, and Ann Lynch. Our Ann Lynch is there, and I'm really thrilled that Ann is here today. And if you don't know Ann, I encourage you to go say hello to her. She's a really good person. Buy her a drink. Now, attached to that meeting, Terry organized a decision support system workshop, because that was the hot thing of the day. And so he not only organized or chaired the organization of the conference, he did this meeting attached to it, and of course edited and published the proceedings. In 1997, he was on the Western Forest Insect Work Conference organizing committee for the meeting in Prince George. And because he hadn't had enough in 1995, he chaired the organizational committee for the ESC meeting again, this time in Kelowna. And there's Terry at the Grand Hotel. If any of you were at that meeting, you know it was just a fabulous meeting. Very, very well run. A lot of good sessions and good social times. Now, of course, Terry once again organized another meeting attached to that, and this was a very significant one. It was a symposium called the Mountain Pine Beetle Symposium, Challenges and Solutions. And this had participation from all kinds of researchers, industry, and government representatives. It really represented the state of the art in mountain pine beetle biology and management for the year 2003. And of course, once again, he did publish the proceedings. He edited and published the proceedings from that, and it is a bit of a landmark publication. If you don't have a copy of it and you do deal with mountain pine beetle, it is worth having one. I believe you can get them in PDF format from our website. If you can't, I do have some extra hard copies, and I can be bribed with beer. Terry also served on the Western Forest Insect Work Conference Founders Award Committee. He organized and chaired many, many WFIWC workshops and symposia. And he became the president of the Entomological Society of Canada in 2008. Terry absolutely loved WFIWC and professional societies in general, and he really contributed a lot to them. And I can say, with all honesty, receiving this recognition, the Founders Award, would have been such a great pinnacle of his career. He would be so pleased to have received this. I can't tell you how true that is. Now I'll move on to my third and final chapter, and this is some observations and lessons learned. And the first, this is more for the graduate students and really young professionals. I think it's worth getting involved early in professional societies. I think that part of the reason that Terry was able to carry out so much relevant work was because of the inspiration and ideas he got from being so involved. I think that it afforded him collaboration opportunities and a great deal of camaraderie. It's well worth your time to do it. I think it's good for your career. It'll be good for your soul. Now, this is one for me. I spent hundreds, maybe even thousands of hours on the road, in the field, with Terry and Les and other coworkers, and I have pictures of beetle galleries and pitch outs and dead trees, and I have almost no pictures of my colleagues, and I really regret that. So, you know, take pictures of your colleagues. You'll appreciate it one day. Ranting can be good for the soul. Those of you who know Terry, excuse me, know that he was absolutely famous for his rants. Now, when Terry ranted, he was not whining. He was shedding light on some of the ridiculous bureaucratic nonsense that we all get shackled with. And it's even worse today. It absolutely makes me chuckle to imagine what he would rant about if he had to fill out the kind of travel applications that we have to deal with today. But I think it was really good. It was very therapeutic, and we all enjoyed it because, you know, you've got to be able to laugh at these things sometimes, or it gets really oppressive. And Terry was an absolute master of that. Don't ever take your colleagues for granted. Things change, and suddenly people aren't there anymore, and it's just value them while you're with them still. And find a way to laugh no matter what. Terry did, even in the midst of some pretty difficult circumstances. And I bring this up because something I didn't talk about was that Terry faced some very, very big challenges in his life. Some of you will know, but not everybody will. But in the mid-1980s, Terry's kidneys failed because of a genetic condition. Now, he did receive a transplant from his sister, and it saved his life. But he suffered many complications and illnesses as a result of this. And in fact, at his most productive years, he was often very, very sick. If you didn't know about it, it's because Terry would never complain about it. He really, that was not his way. He definitely was always maintaining a good sense of humor and through that. But that's why I say, find a way to laugh. And that was something that I learned from Terry. But sadly, in 2008, this kidney began to fail, and there was no possibility of another transplant for him for a variety of reasons. So Terry left government work, and he really just wanted to spend time with his beloved wife, Charlene, in sunnier climates. And this is my other lesson that I learned, is that the people you love are far more important than the work that you do. And keep that as a priority. Terry did enjoy life as much as possible before he passed away in, it was 5 years ago, 2010. So Terry, he is greatly missed, but his impact and his influence live on. And Terry, he's been immortalized by his significant contributions. He has a risk rating system that is used that will be for the foreseeable future that's got his name on it. But those of us that knew him, we remember him for his incredible sense of humor, his ability to laugh, and his ability to make us laugh. We remember him for his incredible generosity of spirit and his character. And finally, more than anything else, the lesson I've learned is that those are the things that matter the most. Thank you.